Organic Chemistry Day 2. I will use tables P and Q to help us name hydrocarbon chains. Alright guys, well I see the word hydrocarbon. So hydrocarbon is a mixture of two elements together to form a long chain. Hydrogen and carbon. Which compound has a low melting point and insoluble in water? Well, we learned yesterday that is a characteristic of organic compounds. Think of yourself. Okay? Organic compounds are made of which element? Carbon. Yes, I know the answer is already given here. Okay. Let's move on. So, let's familiarize ourselves with tables P and Q. Alright? Well, table P says the prefix of the word. As you know, back in English, the prefix is the beginning of the word. So, for example, if I see the compound as the word meth, that means one carbon. Eth, two carbons. Prop, three carbons. Bute, four carbons, so on and so forth, all the way up to dec. All right? Now, the suffix of the word is on table Q, the homologous series of hydrocarbons. Well, what does the word homo mean? Homo means the same. So, for example, if I have a compound that has meth, and then it says ane, such as methane. Methane is found in natural gas, in your oven. I guess when you pass gas by yourself. All right. Another compound you might be familiar with is propane. Propane is found in barbecue tanks. All right. Other compounds, butane. That's found in lighters. Okay, a lighter. Okay. Now, the compound says butene. Well, let's go back over here. Ane means what? That there's a single bond between carbons. Ene means there's one double bond between carbons. Like ethene, F is two carbons, right? Two carbon atoms with a double bond. Ine means what type of bond between? Yes, one triple bond between them. Okay. All right, so let me show you some examples over here. All right, so first compound I want to do is called methane. So methane, which is right here. Okay. Methane says here all single bonds between carbon atoms. And there's something called a general formula, which is CnH2n plus 2. It says CnH2n and CnH2n minus 2. So very simple, guys. The N represents the number of carbon atoms. So if I have the carbon C1, right, there's one carbon. And then 2 times 1 plus 2. So that gives me CH4. So the general form of CH4, or the structure, the molecular form of CH4, well, structural means we're going to draw it out. So we know we have one carbon, and we have 4 hydrogens. Well, we know that carbon always has 4 bonds. 1, 2, 3, 4. Okay, there's no such thing as methane, no such thing as methine. Okay, let's move on to another compound now. Compound that has 2 carbon atoms. F, and then ane. Do ethane. We'll do ethene. And we'll do ethine. So let's draw them all so we see what they look like. So we know there's 2 carbons, right? Ane means all single bonds. So there's a single bond between them. And each carbon always has how many bonds? 4. So the middle carbons, or the 2 carbons, have 1 bond attached to it. 2, 3, 4. 2, 3, 4. Ethene, Eth is 2 carbons with a double bond in between. Now, how many more bonds each one of these on the left and right? Well, they already have 2 in the middle. 2 more, right? Now, I can put it anywhere, top, left, or top, bottom, or bottom, it doesn't matter. Well, I know I need 4, so I'll get rid of one of these. So, by the way, whatever you do on the left, you want to do on the right. So, you put the hydrogens up here. Ethene. Ethine, eth again is 2 carbons. Triple bond in between them. 1, 2. So we only need one more. So I'll do one on the left and one on the right. Okay, let's move on. We'll try to do all these, we'll see. Okay. So next compound's propane, propene, propine. So propus, again, CnH2n. So plug the 3, C3, 2 times 3 plus 2. That's C3H8. So let's see what's correct. 1, 2, 3. Single bonds. Each carbon needs 4 bonds, right? There's 1 here, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh, sorry about that. Alright, so here we go. Propine. Let's try propine. Well, this says there's 1 double bond. So I could put it on the left or the right. So I'll put it over here. There's only 1, and the rest is single. So the carbon on the left has 2 bonds already attached to it. So I'll add 2 more. 1, 2. So that's 3, 4. The middle carbon has 2 on the left and 1 on the right. So 3. I can put a top and bottom. I'll just put a bottom. And the right side carbon has 1 bond attached to it, so I need 3 more hydrogen to make 4. 2, 3, 4. I don't know why it's doing that again. That was propene, by the way, not propine. So let's say if I do, let's skip down to pent. Pentane is 5 carbons, single bonds. So just fill in the sticks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's go to pentine. 5 carbons. So there's 1 triple bond, right, guys? So there's 1 triple bond. You can put it anywhere, but it's because it's propentine really means 1 pentine. No, it's a triple bond. That's my mistake. So I'll put a triple bond usually, right? Because guys, we usually do from left to right. So let me put a triple bond over here. Because it says 1 pentine. Now, carbon can only have 4 bonds around it, so you gotta be careful when you do that. Okay. So let's draw 3 heptine. Hept is 7 carbon chain. 1, 2, 3, 4, 5, 6, 7. Ine means there's a triple bond. But where's the triple bond located? Oh, number 3 carbon. So we got to count. Now, I suggest when you do left to right. So this is 1, 2, 3, 4. So it's in between the 3 and the 4 carbon here. I put a triple bond here. Okay? Now, carbon left, number 1 carbon's got 1 bond. 2, 3, 4. The second one is 2 bonds, right? 1 to the left, 1 to the right. 3, 4. This bond, the number 3 carbon, already has 4 bonds attached to it. 1 to the left, 3 on the right. Same as number 4. So you just finish the rest. These are all your hydrogens sticking out from the outside. Okay, press pause and then try 4-nonene. Okay, non, corn tail P is 9 carbons. 4, 5, 6, 7, 8, 9. Ene on table Q means it's a double bond. Where's the double bond located? Double bond is located number 4 carbon. 1, 2, 3, 4. Going count from the left. Put a double bond there. So this carbon's got 1, 2, 3, 4. These are all hydrogens outside, by the way. I just don't feel like drawing all the hydrogens. It's just too many to draw after a while. Okay, let's do 1, 2, 3, 4. Now this one has 1 on the left and 2 on the right, so that's 3. So you need 1 more. I can put top or bottom, does not matter. Put 4, 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 2 pentyne. Pent means it's a triple bond. Sorry, it's 5 carbons. Yne means a triple bond. Okay, so there's a triple bond there. I'm sorry, triple bond there. On the number 2 carbon. I can count from left to right. 1, 2. So it's going to be not between the 1 and 2, because you always choose a lower number. So that would be 1 pentyne. So it's got to be between the 2 and 3. So the lower number between 2 and 3 is 2. So I put a triple bond there. Okay. Now, this says 1, 2, 3, 4. This array has 4, the second carbon. The third carbon has 4 if you count the left and right. 2, 3, 4. 1, 2, 3, 4. Decene. Dec on tail of P is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ene means a double bond on a number 3 carbon. So 1, 2, 3, 4. Double bond. So fill in the hydrogens here as you go along. Again, carbon can only hold 4 bonds around it. No more, no less. Okay, that's it.